These are some of my favorite math stories. In this episode, mathematics is sabermetrics. We'll look at sabermetrics, the baseball analytics made famous by the book and movie Moneyball. As you may know, the name sabermetrics was coined by the man, Bill James, who gets his own episode. The metrics part means we're looking at statistics, and saber comes from SABR, the Society for American Baseball Research. While various forms of baseball analytics have been around since the formation of leagues in the 1800s, the acceptance and use of analytics skyrocketed in the wake of Michael Lewis's book Moneyball, which showed how the Oakland A's used analytics to succeed despite crippling finances. The movie Moneyball pushed analytics into the mainstream, an important development since the mainstream press can put severe pressure on management and players to use or not use ideas. One specific takeaway from Moneyball has been that on-base percentage is a better measure of batting success than batting average. Since batting average was popularized in the press in the 1800s by Henry Chadwick, it has been firmly entrenched in baseball minds. We all know that 300, hits in 3 out of 10 official at-bats, is good, and the Mendoza line at 200 is unacceptable. By the way, isn't it great that Bob Uecker finished his career with around .200 batting average? On-base percentage, OBP, is a similar stat, but counts walks the same as hits. A player who comes up 5 times, has 1 hit, makes 3 outs, has a walk, would have a BA batting average of .250, 1 out of 4, the walk doesn't count, and an on-base percentage of .400, 2 out of 5, the walk does count. Is this performance mediocre, .250? Or very good, .400. You could argue that getting on base is the goal, so give equal credit to the walk. Or, walks don't move base runners along as much as hits, and it's not really hitting the ball. While we love stories and arguing, a fundamental point of analytics is that opinion should be based on facts. So how do we compare batting average and on-base percentage? Bill James suggested that the idea is to win games, which you do by scoring runs. Why was this controversial? We should see how batting average and on-base percentage compare to runs scored. So here are 2 plots, each of which shows 1 point per Major League Baseball team in 2002 Moneyball era. In the first, we have batting average horizontal and runs vertical. For example, the Oakland A's had a team batting average of .264 and scored 884 runs. It does stand out, doesn't it? A below average batting average, but very high runs scored. If I gave you a team's batting average, could you predict how many runs it scored? Generally, the higher the batting average, the more runs scored, so there's a decent correlation and ability to predict. But for a team with a batting average around .265, there's a wide range of runs scored, so you wouldn't have much confidence in a single prediction. Well, here's a scatter plot using on-base percentage and runs. Oakland had an OBP of .345 with the 884 runs scored. Doesn't stand out as much. An above-average on-base percentage and above-average runs scored. Try the same thought experiment. Knowing OBP, how accurate would your predictions be? Again, the higher the on-base percentage, the more runs scored. Compared to batting average, the data are more tightly packed, and your predictions could have much less plus-minus error, and that makes on-base percentage a better stat than batting average. Correlation is a metric for how much plus-minus there is. If the data are exactly on a line, predictions are perfect, and the correlation is 1 or -1. On-base percentage and runs have a correlation of .926, better than the batting average and runs correlation of 843. An early downside of on-base percentage was its lack of familiarity. A batting average of .330 is excellent, but how good is an on-base percentage of .330? It takes a while to figure out the scale. Here are top 10 and bottom 10 for the 2025 season. For on-base percentage, high 300s is good, below 300 is not good. When I show Roanoke College's basketball coach, Clay Nunley, a new statistic, he always very astutely asks how he is supposed to use it. That is, what is a good value and what is a bad value? How much can they vary? Even if there is good logic behind a stat, we still need the story that goes with it. So, can we do better than on-base percentage? An early sabermetric book, The Hidden Game of Baseball, introduced the statistic OPS, which is on-base plus slugging. Slugging percentage is another classic baseball stat, computed the same as batting average, except that doubles count as 2 hits, triples as 3, and home runs as 4. OPS adds on-base percentage and slugging. Does that make any sense? In golf, there's been an official stat called total driving, which add the golfer's rank in driving distance to their rank in fairway percentage. I've made fun of that one for years. Why would you add ranks together? Okay, I should be fair. Why would you add on-base percentage and slugging? Because OPS correlates well with runs scored. At 934, it is not much higher than on-base percentage in 2002. Here's the plot. But in most years, OPS has a much higher correlation than on-base percentage, which in turn is generally higher than batting average. And to be clear, if those correlations change, then the analyst will change the story being told and go with whichever stat has the higher correlation. Now, there was a very important point hidden in what I said there. A good statistic needs to be consistent, also called persistent or sticky. If I have a statistic for clutch hitting that ranks Mike Trout in the top 10 one year, in the bottom 10 the next, in the middle of the pack the next, then you should suspect that the statistic is not measuring Trout's skill at clutch hitting, if it is measuring anything. So either the statistic is not good, or what it tries to measure is not a real skill. And that's the case for most measures of clutch ability. There either aren't players who are consistently clutch, or we haven't figured out how to measure it. Bill James suggests not jumping to a conclusion as to which of these is true in a thoughtful paper entitled Underestimating the Fog. That is, the fog of extraneous, seemingly random factors is so thick it may be hard to identify a skill if it is really there. One way to measure the consistency of a statistic is to pair a player's stat in one year with the same stat the next year. Presumably, the player's skill would not change much from year to year. Do that for as many players as possible and compute the correlation. The higher the correlation, the more consistent the stat is, and the more confident you can be that the stat is measuring a real skill. Here's what Baseball Prospectus found. For batters, batting average, on-base percentage, and so on. For pitchers, win percentage, batting average on balls in play, and so on. Here are some stories based on those numbers. Pitchers have less control over outcomes than batters do, but pitchers do have some control over whether a batted ball is a ground ball or a fly ball. There are things such as ground ball pitchers. Batters and pitchers have some control over strikeouts, walks, and home runs. Pitchers have much less control over earned run average, and winning percentage is almost random. Neither pitchers nor batters have much control over whether a ball in play is a hit or not. The XBA stat for batters is based on exit velocity and launch angle, and it's the expected batting average given those two values. It has more predictive power than actual batting average, which is again not as good as on-base percentage. Win-loss record does not say much about a pitcher's quality. Some of these ideas ruffle feathers, and the numbers cited don't prove that the statements are correct. But if you're using all of the information available to you, you have to believe that something is going on that you can act on to gain a competitive advantage. And that's what Sabermetrics is all about.